Hello, my name is Michael and welcome to the near clip plane tutorial. In this tutorial I will talk about what the near clip plane is, what it does, and how you can see it in runtime and experience the near clip plane in runtime. I will also talk a little bit about z-fighting, and that's basically the topics I will cover. So first things first, where can you find your current near clip plane value? Just go under project settings by going under edit, then project settings, then on the left panel under all settings, click on it, and then under the search bar you just search for near clip plane. It will display your current near clip plane value, and right now mine is on 30. 30 is not just an imaginary number, it's measured in centimeters. So if I would type in 100, it would be 100 centimeters. That's pretty easy, right? So one important note, if you change your near clip plane value, you will need to restart your project again. So this can be a lot tedious if you want to experiment with the near clip value around. So I have a better way of doing it, so you can actually test it in runtime and experiment with it. So just close it and just go into your character blueprint. I hope you have one, or your blueprint which you are actually playing with. Mine is a third-person character blueprint. So I will double click on it and I will use the numpad 7 and the numpad 9 to increase and decrease my near clip value, near clip plane value. You can use any key you want, but you just need to keep track which keys you use. Okay, so I will just use the numpad 9 and numpad 7, like I said. So I'm right clicking in here in the event graph, type in num9, and I will also right click again, type in num7 and select the num7 here. Now the num9 will be used for increasing the value and the num7 to decreasing the value. Now the next thing we need to do is to have a float, which is basically just a comma number, and use it to change our near clip plane value. So go on the left panel under Add New, click on Variable, and then type in near clip plane value. Go on the right panel on the variable type and select the float one. Compile it and save it. Now click on the near clip plane value here on the left panel. Then go to the right panel under the near clip plane value and type in something like 10. So we have a base value which we can modify. 0 is not a good idea because it will basically just occlude all things, which we don't want. We want to see things. Okay. Now we will drag the near clip plane value out, select get, and then we will also again go to the near clip plane value here, drag out, and select set. This set node should be copy pasted to the num7 too, so we have these two rows. And then we want to increase and decrease these values. We do that by using a plus or minus node. So for the first one, where we want to increase our near clip plane value, we will use the plus, because the more we increase it, the higher the value should be. So drag out the near clip plane value from this one here. Then type in the plus sign and then select the float plus float. We will, well, change it in 10 steps. So we type in 10 down here. You can also use a different value if you want. I just will increase them in 10 steps. Then just take this return value and plug it into the near clip plane value up here. Then just connect the pressed of the numpad 9 key and connect it with the set node. Okay, we do the same down here, just with a minus node. So drag out from this pin here again, type in the minus sign, take the float minus float, and type in 10, like up here, and connect it to the near clip plane value of the set value here. Connect it with the pressed numpad 9, and we have the first part set up. The next part is to actually execute a console command, so we will be able to adjust the near clip plane value. So just right click, type in console, and select the execute console command and put it right here. Now we need a command, but because we want to increase it and decrease it, we can't just type something in here with a set value. So in order to do that, we just right click, type in append, and select under string the append node. What this basically is that it takes the B value and adds it to the A value. Numbers are normally green or kind of cyan, but these are pink, and that means they are strings. Strings are just text values or characters, and we can't just use this one here because it's a float value and put it into a string value. We would need to convert it, but first we want to actually set this here up before we solve the other problem. So we connect the return value of the append node to the command because we want to execute what is written in here. And we can already connect the set node up here to the execute console command, and the same here with this set node to the execute console command. Now, here comes the thing. The console command for the near clip plane is called r.set near clip plane. And don't forget a space. So we press one time space. That's because a value will not be applied if we don't use the space. And that's because the value will just be added to the A value directly after the E. And we don't want that. So keep in mind there should be a space after the E. Now in the second one, we need to convert our current value, our number, to a string. So just connect this one with this one here, and it will create this little conversion node. So it is actually being converted to a text or to characters. Now our near clip plane value will be added to the r.set near clip plane command, and we will execute this console command every time we press the num9 key or the num7 key, and it will always use our near clip plane value, at least our variable. That's it. You don't have to do anything anymore, and we will jump right in and see if this actually works. So, okay, nothing is happening because we don't increase it enough. And we can't see if we actually change something. To check it, and it's a very important note I always use. So right click, type in print string, and select this one here. Connect it to the execute console command, and just connect the return value of the append to the int string. Compile it, save it, and then press play again. Now we will try it again, go close to a mesh, and we will increase it with a 9 key. And you will start to notice that we are actually occluding more and more and more the farther we increase it. So we are right now on 1000, which will just look like a weird big glitch. So you see a value of 1000 will not work pretty well in a third person game. Okay, so what does it actually do, this near clip value? Basically, the near clip plane is the distance between the camera itself and the meshes in the scene. All things are basically being rendered in the camera. So there is no thing like off-screen rendering or such. Just things which are in the focus of the camera will be rendered out. That's because it would basically make it impossible to create games if you would render all things off screen. It would just be way too much way too much burden for the computer to do that, and it wouldn't be fun, and it would just run with maybe 0.5 FPS or anything like that. That's why just things which are in focus of the camera will be rendered. So that's basically the point of 3D rendering, because without the camera the scene would be empty and black. So these are just basic principles of 3D rendering, and the near clip plane means basically how far things will start to occlude. So, for example, the near clip plane value, this refers to the camera itself. So the more you increase it, the more you go away from the camera. So all things below this value will be occluded or will be cut out from the rendering process. They will not be rendered. All things above this value will be rendered and will appear solid and not cut out. So that's what basically happens. So if we increase it here, you will see that it gets farther away, the near clip plane, and it occludes bits for bits with on other meshes. So this is what the near clip plane actually does. Now, the near clip plane is actually one of two components. There's also the far clip plane. As far as I know, you can't change the far clip plane except you want to delve deep into the code of the Unreal Engine, which for the blueprint average user or maybe expert user is a little bit too much just to change the far clip plane. The only thing you can change is the near clip plane. I will later on, I think I will show it right now to you, so you can actually see what the far clip plane is. So let's have it on 30. Right now we have our temple on 1 meter. It's 1 times the size of the temple. The cube here is 1 meter in the Unreal size or in the Unreal measurement. The next temple is 10 times. So it's 10 meters big, and it's 10 times bigger than the initial temple of 1 meter. And it looks like this. Nothing big is happening. We can even increase the near clip plane. So there's nothing really happening here, right? So let's get it back to 30. Okay. Oops, that was too much. Okay, now this one here is 100 times bigger than our initial temple, and it's 100 meters big. I already fit through it, and it's pretty spacey, right? So the next one here this one here is 1000 times bigger than the initial temple mesh, and it's roughly in size of 1 kilometer in the Unreal Engine. When you look at it, it's really big, but nothing happens, so it doesn't clip out or anything. And when you look at it, it's really spacious. But we will get to the next one. This thing here is 10,000 times bigger than the initial mesh, and 10 kilometers in size in the Unreal Engine. That's pretty fucking big. But you will start to notice something on the right side. Some things are being visible right now. Some things are being faded in. And some things are fading out. So things are not being rendered properly anymore. And this is just gigantic in size. Now, what happens there actually? This, what you see there in the background, is the far clip plane. So our rendering process is always measured or calculated between the near clip plane and the far clip plane. All things which are behind the near clip plane and the far clip plane are not being rendered. So you see the problem in not changing the far clip plane. It basically reduces our ability to create unlimited sized buildings or landscapes or any kind of object. So one tip for people who actually want to have big worlds, maybe a space simulator, maybe maybe just really big landscapes, or maybe you just want to have some buildings or some real life geometry and take the real life units and apply them on the Unreal Engine. This will basically just not work because this occlusion will happen too. So one tip for the people who want to create these massive games, if you have some kind of real life scale in mind, use something called a conversion ratio. That just means that you take 1 centimeter and you divide it through a certain number, like maybe 10. So it goes down to down to the scale of 0.1, or maybe 100, where 1 centimeter is 0.01 centimeters then. So if you want to create these big kind of games, you should implement such a ratio so you can scale your objects in the Unreal Engine and not run into that kind of problem. But it will still represent the same, the same scale like in real life, because you will just convert a certain measurement and convert it down to a certain ratio, or with a certain ratio. So that's just for the people who actually want to create big worlds. Just scale them down. You might run into a problem with collisions, but you have to try it out how it actually affects the game, and you need to experiment with it. But scaling down is probably the best way to go to avoid these kind of things and glitches, basically. Now, what can you do with the Near Clip Plane 2? You can also use it for a hack and slash game, for example. Because if you run into a structure, maybe even a cave, or maybe even a dungeon, you will want to occlude the walls so you can clearly see your character, or else you will not know where you are moving towards. So this is a pretty important thing, and you can use it for that. I personally think using the near clip plane value for occlusion for a hack and slash game is not the best looking solution, but well, what floats your boat? You can do whatever you want. Just try it out and see if it works for you. But there are certainly better ways to do it. Now, so changing the near clip plane, and I will show it right now, like a ridiculously high number, will not affect anything. So if you have or if you fear that that something called Z-fighting is happening, so it is basically flickering of meshes in the distance, or maybe even right before you, the near clip plane value will do jack shit for you. So changing the near clip value to avoid Z-fighting doesn't do anything. So don't try it. It's pointless because you can't change the far clip plane. So I need to bring it down first. So just for people who want to create RPG games with a third-person character, a value of around 10 to 30 will probably work best. Like here. If I increase it to 20, it kind of cuts out, but 10 will work best for a third-person RPG. It doesn't really decrease or increase the performance. I made a lot of tests and it doesn't do anything. So if you have a near clip value of 10 or of 1,000, it isn't noticeable. Let's say it that way. Now, the last thing I want to talk about is Z-fighting, so you can actually see what happens here and how you could avoid it. Also, something to increase the precision of the Z buffer, which is basically the depth information of the scene itself. So first off, what is the Z buffer? The Z buffer is basically the depth information of the whole scene. So without the Z buffer, you wouldn't be able to see things in 3D. You will just have a 2D game. So in order to have 3D objects here, the Z buffer is working, or was invented, and the Z buffer is called the scene depth in the Unreal Engine. So these two are essentially the same thing. So the Z buffer is the scene depth in the Unreal Engine. Okay, now when the Z buffer is at work, it will not just render a color, or rather a pixel, it will also store a certain value, a depth value in this pixel. But there's one problem with this Z buffer. The Z buffer works with the camera itself, and the more the camera, or the more of, sorry, I have to rephrase it. The more objects, or the bigger the objects are which are occupying the camera, the more depth information or precision is lost. So Z-fighting will increase if you have more space of the camera occupied and have bigger objects which will occupy the camera. Just a hint, the camera view itself, which is being rendered, is called the view frustum or the camera frustum. Just a note. So the camera will just, or rather the Z buffer will lose precision, and if multiple or bigger objects or a lot of objects are occupying the camera, and this will result in something called the Z-fighting. Z stands just for Z buffer, and fighting, well, you will see why it is. Yeah, you will see it now. They will try to fight for the position to being in front of all the others. So what happens here is actually, like I said, a depth value is being rendered at the rendering process, but your computer is being updated at a frame per second, and the old value will be compared to the new value. If the old value was modified, the frame will be recalculated, and the render will be applied anew. That will result in, maybe in the frame 1, the mesh which is in front will win this fight. So another object or another mesh is behind the front mesh. But in the frame 5, the mesh in the background will win the fight and will be displayed in front. So they are actually always changing position, because the meshes always go in a win-lose situation. And one mesh will just be displayed in the front, and the next frame just in the background. And that's why this flickering is happening. So in order to avoid this Z-fighting, or rather decrease it, is to either just not overlap meshes, because you will see I overlap meshes and this is happening. It especially happens a lot with transparent meshes, so keep that in mind. Or you can space out the meshes a little bit more, so the objects have more space between them. This will also decrease this flickering and Z-fighting, because these things are not occupying the same space in the view anymore. Here they are. Here they are not. So you have to experiment a little bit to avoid this Z-fighting, and maybe, well, structure your level design in such a manner that you have always a little bit of space between objects, especially if these are transparent objects. Now, the last thing I wanted to mention is you can also try a different thing to increase the precision of the Z buffer. This will basically, I think, be a little bit more performance intensive. I don't know how much, but it will decrease the Z fighting. At least that's what it should do. I don't know really if it works. It's a command I found in the Unreal Engine in the documentation, and it was recommended that this should work. And basically, it is called r.setgbufferformat. Sorry, not set, but r.gbufferformat, and then the value. You would think it would go up to 5, but the thing is, the gbuffer format can only have a value of 0, 1, and 5. 0 is minimalistic rendering, so the depth information is poor. 1 is the default engine, or the default value of the Unreal Engine. And 5 is a high precision scene depth buffer. So this will increase the depth information, or the depth precision. But like I said, I couldn't really test it out if it works or not. But that's stated in the Unreal documentation that it should work, and that you can decrease the fighting with using this command. Okay. I have covered a lot of things. I hope I didn't confuse you. And yeah, well, basically, just to summarize it, the near clip plane doesn't do a lot. It isn't performance dependent. The far clip plane is much more important, but you can't really change it. And you have to experiment a lot with the near clip plane to find your golden value. And for RPGs and third person worlds, something like a value of 10 to around 30 can be used, but I rather would go for 10. And for such things like the hack and slash genre with an isometric view, you can go higher than 30, 50, maybe 70. So you can actually use this occlusion feature too if you want to. In RTS you can even crank it higher, above 100 even. But no, and I say no game will probably use a ridiculous number like 1000 centimeters of the near clip plane. Okay, I hope it was helpful. I hope I didn't confuse the hell out of you. Right now I'm pretty tired because I'm not so used in talking in such a long time. And I hopefully see you next time. So goodbye and have a wonderful day.